Hello everyone, I am Prajwal. Now I am going to talk about the analyze the single line diagram of your local substation under the guidance of Professor Arjun JOSHI sir. First one is single line diagram. A single line diagram is also called one line diagram. It's a symbolic or geographical representation of three-phase power system. It has a diagrammatic representation of all the equipment and connections. The electrical elements such as circuit breakers, transformers, bus bar, and conductors are represented using standardized schematic symbols so that they can be read and understood easily. In a single line diagram, instead of representing each of three phases with separate lines, only a single conductor is represented using a single line. A single line diagram makes it easy to understand an electrical system, particularly in the case of complicated system in substations. It helps in detailed study and evaluation of system and its efficiency. Next is advantages of single line diagram. It gives an overall understanding of the system and easiest evaluation. It simplifies the troubleshooting process and makes it faster. It further ensures the safety of personnel and makes maintenance more convenient. It ensures a safer and more reliable operation of the system. Then after that, important symbols of a single line diagram. Isolating switch. In power substations, it is required to disconnect a part of the system for general maintenance and repairs. This is accomplished by an isolating switch or an isolator. An isolator is essentially a switch designed to open a circuit under no load. For example, if the entire substation is divided into 5 sections, each section can be disconnected with the help of an isolator for maintenance. Next is bus bar. A bus bar is an assembly of bus conductors with isolated associated connection joints and insulating supporters. It is grounded metal enclosures containing factory mounted insulated conductors, usually copper or aluminum bars, rods, or tubes. Next is circuit breakers. A circuit breaker is a circuit component that can open or close a circuit under normal and fault conditions. It is designed such that it can be operated manually under normal conditions and automatically under fault conditions. It is a special type of switching device which can be operated safely under huge current carrying conditions. It is used for timely disconnecting and reconnecting different parts of the power system for protection and control. It is transformers. Transformers are essential components in power transmissions and distribution. They are used to step up and step down the voltage. Mostly at the power station, a step up transformer is used to increase the generated voltage to a higher value. At subsequent substation, a step down transformer is used to reduce the supply voltage and then finally deliver it at the utilization end. This is the single line diagram of 11 kV 400 volts indoor substation and its explanation. The three-phase three wires 11 kV line is tapered and brought to the gang operating switch installed near the substation. The gang operated switch consists of isolators and connected to each phase of three-phase line. From the GO switch, the 11 kV lines is brought to the indoor substation as an underground cable. It is then connected to high voltage or primary side of the transformer of 11 kV 400 volts. We are the 11 kV oil circuit breaker. The transformer steps down the voltage to 400 volts, three-phase, four-wire. A single-phase residential load can be connected between any one phase and neutral. A three-phase 400 motor load is to be connected across three-phase lines directly. Current transformers are located at suitable places in the substation circuit and supply for the metering and indicating. Secondary of the main transformer supply to the bus bars through the main circuit. From the bus bar 400 volts, three-phase, four-wire supply is given to the customer via 400 volt circuit breaker. The voltage between any two phase is 400 volts, and that between one phase and one neutral is 230 volts.